In this lecture, we will discuss about the various braking method of induction motor drive. There are three types of method for induction motor drive. Three type braking method for induction motor drive. One is regenerative braking. Another one is the plugging or reverse voltage braking, and third is the dynamic or rheostatic braking. The dynamic braking has four parts: AC dynamic braking, self-excited braking using capacitor, DC dynamic braking, and zero sequence braking. In today's lecture, we will discuss about the regenerative braking and plugging or reverse voltage braking. In the upcoming or next lecture, we will discuss about the dynamic braking and its parts, various parts. So first, we will discuss about the regenerative braking. In the regenerative braking method, the induction motor, which is working as a motoring mode, will work in a generating mode. Means the motor is work itself as a self-excited induction generator. We know that the electrical power is given as an input to induction motor drive. If this motor is work as a generator, the expression of power will become negative. Means the motor is not receiving the power, instead it gives the power. So the expression of an induction motor input, which is given input to induction motor, which is given by P input 3 VIS cos phi s. So to become an induction generator or motor will work in the regenerative mode, this expression should be negative, and this expression will become negative when the angle phi s should greater than 90. If it is less than 90 degree, then the motor work as a generator, motor work in the motoring mode, and if phi s become greater than the 90 degree, this expression will become negative. The expression will become negative and the motor will work in the generating mode. So to become phi is greater than 90, the rotor speed become greater than the synchronous speed. If it will happen, the relative speed between the rotor conductor and air gap rotating field reverse. Means the slip, which is given by omega ms minus omega m upon omega ms. Omega m will become greater than the omega ms, though the slip will become negative. Means when the slip will become negative, this reverse the rotor induced EMF, rotor current, and the phi s will become greater than 90, which is the phase angle between the stator phase voltage V and stator phase current Is. So whenever the phi s will become greater than 90 degree, the slip S will become negative or S will become minus S. When we put the S, we replace the slip S with the minus S in the basic equation of induction motor drive and draw the characteristic of that. In that case, then the characteristic will occur like that. In the quadrant 2, the regenerative braking characteristic will appear, which is the extension of motoring characteristic in the quadrant 2. So when fed from a source of fixed frequency, regenerative braking is only possible for speed greater than the synchronous speed. Means when the phi s will become greater than the 90 degree or speed of the motor will greater than the synchronous speed, then only that case the regenerative braking is possible for a source of fixed frequency. But with a variable frequency sources, it can also be obtained for speed below synchronous speed because the synchronous speed omega ms, which is given by 120 f upon p, when the frequency has been changed, so it can be possible below the synchronous speed also. This another method or second method for braking is the plugging or reverse voltage braking. In this method, when phase sequence of supply of the motor running at a speed is reverse, means when applied the reverse voltage by interchanging connection of any two phases with respect to supply terminal voltage, operation shift from motoring to plugging of reverse voltage will be applied. Whenever the reverse voltage has been applied, the phase sequence reverse the direction of a rotating field, and whenever the rotating field will become reverse, the omega ms will become negative, means the difference between the regenerative braking and in the reverse voltage braking. In the regenerative braking, the slip will become negative, while in case of reverse voltage braking, the synchronous speed omega ms will become negative. So whenever the omega ms will become negative, the expression of slip in case of plugging, if it is denoted by Sn, it will become minus omega ms minus omega m upon minus omega ms. If we solve this expression, this will become 2 minus s. So the maximum value of slip may be become at the 2. So, so if we plot the characteristic of plugging, when we shift from motoring to plugging case, we have to replace the value of slip in the basic equation of induction motor by the 2 minus s, and then we can plot the characteristic. So when we plot the characteristic, it is the extension of motoring characteristic for negative phase sequence from quadrant 3 to quadrant 2. There are two characteristics are plotted here. This characteristic is the motoring mode characteristic, while there are two characteristics, characteristic 1 and characteristic 2. Characteristic 1 is the natural characteristic of induction motor drive when operating in the plugging case, while characteristic 2 with external resistance, if we insert the external resistance in the rotor circuit, then the characteristic 2 will occur, 2 will appear. As we know that the slip can be up to the twice, slip can be up to 2, the rotor induced voltage can be twice of its value at 0 speed. So in case of wound rotor motor, a resistance equal to the twice the stator resistance is inserted to rotor circuit to limit the braking current. So the characteristic 2 is the characteristic when we insert the a braking resistance. So this also increases braking torque as shown by the curve 2. So in this characteristic we have seen that at a zero speed the torque is not zero. So this method is mainly applicable whenever we have the reverse operation will perform. If we want to brake the motor at a zero speed, we have to do some extra arrangement to torque should become zero. So this is all about the dynamic braking, reverse voltage braking method, and the next method, which is a dynamic braking or restorative braking method. We will discuss the dynamic braking method in the next class.